He also came to the department this last December. If you have heard his talk on Wednesday of a particular week, he is now teaching in one of the Ivy League schools. It's called Dartmouth. And so those are the basic reference and the textbook for this class. And the background you will need is some basic control theory knowledge is good, but then you need strong linear algebra and ordinary differential equations. Okay, and the grading distribution for this course, 40% will be homework. Yeah, again, the homework will be Scilab programming homeworks, most likely from previous years. And then the project will be 20%. And you have 2 midterms, that's worth 20% each. Okay, academic policy, honesty policy, you can discuss, but don't copy, and you can ask your TA. Oh, and yes, I will. So you will get points deducted for plagiarizing. Next, let's see the next slide. The homework will be graded according to these standards. And then next, you can see these on the syllabus later. And take good notes and keep up with the course. 有问题要问，好，老师也会问问题，老师问问题也要回答。然后在下一页介绍我们的助教，这边的助教是林明阳。This is our TA in Cheung Kong University. We also have another TA in 中央大学, and this is a course held in 2 places. Sometimes Dr. Zhuang will lecture maybe over at 中央大学. So if you have questions, you can ask our TA. And this is Dr. Zhuang's favorite line. He translated in Chinese also. And you can take a minute to savor this. Okay, are there any questions? Okay, I'll change slides now. 帮我换一下。Were there 3 students who were assigned to this course? 是有外校的学生要加签的吗？他可能今天没来。Okay. So I will continue with the ordinary differential part of this lecture, and we will finish when I'm finished with this. This is, more accurately, a review of ordinary differential equations, because I assume that you've also taken courses on engineering math. This will be the outline in general. I will have a few supplement slides, but we will talk about homogeneous and non-homogeneous ODEs, review what their solutions are, and then the coupled ODE, which is a generalization of any kind of single variable ODE, and then some concluding remarks. Okay, let's look at the slide that I was, the other slide. So, first, this slide is to show a relationship with the class of classical control theory, the common functions and figures that we use, compared with what we will see more frequently in this course, the equation in state space form. And then we also will have to keep in mind what our physical system is and know its connection. So let me say more about this. Let's start from the physical system, which is a mass spring dashpot system, which is a very basic system. We usually have mass M, the spring constant K, and the dash part will represent some kind of damping, which has a damping coefficient. Let's use beta. For such a system, we want to relate that to a state space equation. This is what we call the differential equation. I know you've all learned this. I just want to make sure the connection is clear, and in the future we will just pick this up and use it without any explanation. What should this first coefficient be? 第一个系数嘛，我们这个我还没有补上系数，然后因为这个是质量，那个补课系数还有那个阻尼的系数，那代表说我在我的那个时域的那个方程式里面会有什么样的一个方程式？你知道我在问的问题是什么吧？很简单呐，所以